Okay, do you remember what our video said, what I should put in these blanks? Similar figures have the same but different. Okay, size goes here. Oops. What goes right here? Same shape, different size. It says it right here. Okay. Okay. Now, figures are similar if two things are happening. First of all, their corresponding angles need to be congruent. So their corresponding angles are the same.
Yes, ma'am.
Okay. Somebody in Miss Ruth's room being obnoxious. I know. Don't be like that when you're in Miss Ruth's room.
I do like that all the time. Or I can just yell right now and just start down.
No, we'll be the bigger people. Okay, corresponding sides are proportional. Sorry. I was making sure I spelled it right. Write those things down. We're going to talk about what they mean.
Alright, but when I did that, that's what happened. Huh? Leave me alone. We took a lot of money when I did it, and that's what I did. He's writing. Stop that. You don't do it. Oh, when I did that, you want to yell.
I broke the tea.
Yeah. That's right. By the time you fix it, I was fucking going to be done. And I'm not looking there. She didn't go to that. I was trying to do my chocolate up and I got it crashed. And it was like, take it. I just sat there. Like,
All right, here we go. Corresponding angles are congruent. Raise your hand. Tell me what congruent means.
the same.
Same. Corresponding sides are proportional.
Like, the same.
Oh, hold on. Say that again. Okay, they're not the same. They're a different size, but there's got to be something more than just like different size, right? So let me tell you this. Because our corresponding sides are proportional, then we have a ratio of our corresponding sides that we call the scale factor. Okay, which means there's a number we can multiply by to get all of the other sides. Okay. Hey, what does it say on this paper? What were we solving? Oh, we were solving proportions. So what do you think proportional has to do with?
Proportions is in proportional.
Like maybe some fractions that are like equal. Fractions that are equal. Just a thought. Just a thought. Okay, Tony, what you doing there?
What?
What you doing?
I'm trying to fix my shoe, buddy. I feel the best.
Your purple pen.
Okay. what I'm gonna do, before we actually talk about identifying similar figures. And in our notes, I want you to look at these three right here. Okay, I'm gonna highlight side AB. What side in this bigger triangle corresponds with AB? DE. Okay. I'm gonna highlight BC orange. What side in this other triangle corresponds with BC? EF. How do you know that? Notice how B has the 2 swoops and C has the 3 swoops. So we know B and E correspond. C and F correspond. So that side in between has to. Okay. So if I want to answer the question, are these triangles similar? Well, we need our sides to be proportional. So this is what I'm going to do. I'm going to take 4 and 8, and I'm going to make them a fraction, 4/8. Hey, what is 4/8 reduced down to? 1/2. Okay. What's another fraction I can make? Reagan. We can take 5/10. Hey, what is 5/10 reduced to? Okay. Tony, what's the third fraction we can make?
10/8 or 8/10.
Okay, so we've made 4/8. We've made 5/10.
7/14.
And Tony, what is 7/14 reduced down to? 1/2. Hey, what do you notice about the ratio of all of our sides?
They're all the same.
Okay, so this is how we know that yes,
They're all convergent.
not congruent, they are similar. Okay, so let's go back to these 4 right here that you just talked about. I see a lot of people recognizing that number 2 was the one that they're not similar. Okay, so let's talk about number 1. What is a fraction we can make here? What's a fraction we can make? 4/12. And then if we grab this side, 4/12. And if we grab this side, okay, that's lame, 4/12. Do you see how all of those ratios are the same? That means our sides are proportional. This triangle is 1/3 the size of this triangle. Whoa, where's the 1/3 coming from?
Simplify.
Okay, 4/12 is 1/3. This triangle is 1/3 the size of this triangle. Okay, so let's go to this right here. What's a fraction we can write?
5/15 and 7/5.
So I would say we would need to match up 5 and 7. Why? They're both the short sides.
But no numbers go into them.
That's okay. That's okay.
Three goes in the top and 15.
Okay. So you're recognizing that maybe that's a problem. So 12/15, you're saying we can reduce by 3?
Yeah.
And it's now 4/5?
Yeah.
Okay, is 5/7 the same as 4/5? No. So that's why these are not similar. Because our ratios are not the same. Do you see what I'm saying?
I think, Marco, you were right.
Always
Miss,
trust
you made me
Marco.
You made me feel like I was wrong. No.
No, I didn't.
You did. You're like,
However, okay. So, yes, in the basic sense, if the shapes are the same, but different sizes, they're similar. However, these aren't the same rectangles because this one, when you compare like the width to its length, this one is, if I shrink this down, this is going to be wider than this one. Okay. So that's why we have to check if we're proportional. Like if we were to take one and stretch or shrink it, we should be able to get to the same size. But if they're not proportional, we won't be able to do that. Do you understand what I'm saying, Cash? Okay. So let's talk about this triangle. What would I match 8 up with?
12.
Okay, so 8 over 12 and 10 over 15. So what can we reduce 8 over 12 to?
Yeah. 4. No, yeah, 4.
So if we divide each of them by 4, we have what?
2 over 8. My bad. And then you can divide 5 by both of those.
And we would get,
2 over 3.
hey, are those the same?
Yeah.
So that's why these are similar,
That makes sense.
doesn't it? I love it.
Buddy, who's in my
14.
Never mind.
Okay.
Someone put Miss Hunter's on something.
Oh, that's so nice of them. Yeah, I'm gonna go ahead and keep that. Okay, so let's also talk about this right here. So since this number is 2/3, this small triangle is 2/3 the size of this triangle. That's what that means. Okay. Okay, let's go back to our notes, shall we? Okay. We're gonna look at this picture and we're gonna match up all of the corresponding angles. So remember, if we have similar figures, our angles are the same. So we can write that angle A is congruent to angle, what's in the same place as A? D. Angle B is congruent to what?
Angle B is congruent
To E. Is it the congruent?
It's kind of ugly.
It's like when fancy restaurants give you nothing.
Angle C is congruent to angle F. Okay, that's gonna be the simple part of this. Can you move your back so I don't trip?
Thanks, buddy.
Now, if we talk about our corresponding sides, we can make fractions out of our corresponding sides. So if I make a fraction and I choose AB to be in my numerator, what's in our denominator? DE. Because I like hearing you complain. Okay. If I choose BC for our numerator, which side goes in our denominator? Good, EF. If I choose AC for our numerator, what goes in our denominator? BF. So we're matching up the sides together. And notice how with each of my ratios, I was consistent with, I picked the smaller triangle for the numerator and the bigger triangle for my denominator. Now we could flip them upside down and we can go big over small, big over small, big over small. We just have to be consistent with it. Okay, so for example, if I ask you for the scale factor from ABC to DEF, I'm gonna pick one pair of sides. Tony, pick me one of the sides from ABC. 4, 5, or 7.
5.
Okay. And what does 5 correspond with?
It corresponds with. Wait, 10, yeah.
Okay, so I'm gonna write 5 over 10, and that's gonna give me a scale factor of 1/2. Triangle ABC is 1/2 of the size of DEF. Okay. Because it's smaller, right?
So it's similar.
Yeah, it's similar. Now, what if we go from DEF to ABC? Well, DEF, I could grab 10 over ABC, 5. So here our scale factor is 2 because this triangle is twice the size of the smaller triangle. You could do this again, huh? This. Not you. Okay. All right. Now, oops, I want you to write this. Okay. You're going to love this, Kale. We have a symbol for similar. No, it's the squiggle. That's not an equal sign. That's a similar sign. So we're going to write triangle ABC is similar to triangle. We have to make sure we write this in the right order. A corresponds with D. B corresponds with E. C corresponds with F. What? What about it? Yeah, because we're talking about triangle ABC and how it's similar to triangle DEF. You missed probably the best day in class so far.
Really? When was that?
Tuesday.
Bro, why every time somebody misses school, something good happens? Like actually.
Be here all the time.
My
All right.
actually came back and did a concert for the whole school.
All right, now we are going to use this knowledge to find missing measures in a figure. So we are going to use the fact that similar figures are proportional. Okay, and we're going to solve for a missing measure. So, you don't get to judge because you literally just said it to her like 20 minutes ago. I did.
That's like one. No, because you
I'll
made
make
fun
it-
of me, so I gotta say something to it.
No, no. Okay, what side does 2 correspond with?
3, 8.
Okay. 2 and 3 are corresponding. How do we know?
Can I tell you that?
Because they're on the same side.
Like they have.
Okay, so in our parallelogram, 2 and 3 are the shorter sides. Okay. Now that means that 8 Okay, so why am I doing this?
Because they're different.
Okay. So I'm trying to help you see that these 2 correspond and these 2 correspond. Okay. Now we're going to actually write a proportion. So what I'm going to do is I'm going to write 2 over 3 equals. Now, if I write 2 over 3, what fraction am I going to write on the other side?
X over
8 over X.
So I hear 8 over X and I hear X over 8.
8 over X.
Why, Emma?
Because it's hard.
Okay, since we chose 2 first for this ratio, we better choose 8 first for the second ratio. Okay. What I did is I went, hey Cash, I want you to watch this. I took small over big for this fraction, which means I need to take small over big for this fraction. So
8 times 3 and 2.
okay, so the hard part's over, right? You guys showed me that, man, you're great at solving proportions. So we're gonna take 2 times X equals 3 times 8, right?
Yep. And then 8 times 3.
What's wrong? Okay, so we have 2x equals 24. Right? How do I get x by itself?
Put it on the other side, so divide by 2, and then it'll be x equals 12. Just divide that by 2.
Isn't that what I did?
I just didn't write it down.
Okay, but that's what we did. Okay, so that's what we're doing. Okay, now you think so?
Yeah, pretty easy.
Okay. So this is what I want you to do. I want you to go to page 17, and you're gonna only do 1 through 7. No, it's not.
So can I press on 8? Can I press on 8?
No, because we'll do it tomorrow.
Ah,